Students, today let us solve some more problems on derivatives, that is the derivatives of composite functions. The question is same, find the derivatives of the following functions. Find the derivatives of the following functions. With respect to x. Okay? Find the derivatives of the following functions with respect to x. The first question is tan power 4x. Tan power 4x. I'll take this as y. Let y equal to tan power 4x. Tan power 4x can be imagined as tan x whole power 4. So y is equal to tan x whole power 4. Now I will differentiate it with respect to x, that is I will get dy by dx. This is equal to tan x whole power 4. This is of the form x to the power 4. The derivative of x power 4, as we know, which is equal to derivative of x power 4 is equal to 4 into x cube. So derivative of tan x whole power 4 will be 4 into tan x whole cube into the derivative of tan x. Into dy by dx of tan x. That's equal to 4 into tan x whole cube, I can write as tan cube x, into derivative of tan x. Dy by dx of tan x is equal to secant square x. So this is the derivative of tan power 4x. Okay, let us look at the next question now. 1 by root x. We want to find the derivative of 1 by root x. Okay, so now I'll take this as y, let y equal to 1 by root x. 1 by root x. Root x is x power 1 by 2. Take it to the numerator, it will become x to the power minus 1 by 2. X to the power minus 1 by 2. You can directly differentiate it, you know, there is no need of using chain rule here. X power minus 1 by 2, it is of the form x power n. Derivative of x power n is n into x power n minus 1. So here we get minus 1 by 2 into x power n minus 1. Minus 1 by 2 minus 1. That's equal to minus 1 by 2 into x to the power minus 3 by 2. Minus 1 by 2 minus 1 will be minus 3 by 2. Okay, you can stop here, or if you want you can write one more step, that is minus 1 by 2 into x root x. X power minus 3 by 2, I will take it to the denominator, it will become x to the power 3 by 2. X to the power 3 by 2 is nothing but x to the power 1 into x power 1 by 2. X power 1 into x power 1 by 2. So we get minus 1 by 2x into root x. Let us look at the next question. Cos of cube root of x. Cos cube root of x. We have to get the derivative of cos cube root of x. Okay. So now, as usual, we will take this as y. Y is equal to cos of cube root of x. Okay. This looks like cos x. Imagine this as cos of some function. So cos x. Derivative of cos x is minus sine x. So this will become minus sine of cube root of x into the derivative of cube root of x, dy by dx of cube root of x. Cube root of x can also be written as x to the power 1 by 3. Okay, so this is of the form cos x and derivative of cos x is minus sine x. So we got minus sine cube root of x into the derivative of cube root of x. I am writing cube root of x as x to the power 1 by 3. So this is equal to minus sine cube root of x into, here I will use derivative of x power n formula, which is equal to n into x to the power n minus 1. That will give you 1 by 3 into x to the power n minus 1. 1 by 3 minus 1. So this is equal to minus sine cube root of x into 1 by 3 into x to the power 1 by 3 minus 1, that will be minus 2 by 3. Okay. So minus sine cube root of x into 1 by 3 into x to the power minus 2 by 3. See, even when you are differentiating, say for example sine x, if I ask you to find the derivative of sine x, what do? You will directly write that if y is equal to sine x, then y dash is equal to cos x. It's okay. See, even there also you can use chain rule, like derivative of sine x is cos x into d by dx of x into d by dx of into the derivative of x. And what is the derivative of x? 1. So cos x into 1 will give you cos x itself. So that is the reason we don't use chain rule while differentiating sin x or cos x. Did you understand? Instead of sin x, if it is sin 2x, suppose sin 2x, then what happens? There will be y dash equal to cos 2x into derivative of 2x. Derivative of 2x is 2, so the answer would have been 2 cos 2x. Is it clear? Okay. Let's go to the next question. Sine of cos x square. Sine cos x square. Sine cos x square. Okay. I take this as y. Let y is equal to sine of cos x square. Okay. So we can imagine this as sine x. It looks like sine x. What is the derivative of sine x? Derivative of sine x is cos x. So derivative of sine of cos x square will be cos x square. Cos of cos x square into the derivative of, so we have differentiated for this function, now we will differentiate for this, derivative of cos x square. Okay, this is equal to cos of cos x square into derivative of cos x square. You can imagine this as cos x. Derivative of cos x is minus sin x. So derivative of cos x square will be minus sin x square. The problem is not over yet because sin x square you have into what next? Into the derivative of x square. Okay, that minus I will write here. So we got that minus cos x square into sin x square into the derivative of x square, which is 2x. Okay, so you observe here. First we differentiated for this sine and then we differentiated for this cos, and after that we have differentiated for this x square, and hence the name chain rule. Okay, let's go to the next question. The next question is 3x square minus 7x plus 3. 3x square minus 7x plus 3 whole power 5 by 2. 3x square minus 7x plus 3 whole power 5 by 2. Okay. So I will call this as y. Let y is equal to 3x square minus 7x plus 3 whole power 5 by 2. Okay. This is of the form x power n. Treat this as x to the power n. Derivative of x to the power n is n into x power n minus 1. So here n is 5 by 2 into x. In place of x we have 3x square minus 7x plus 3 to the power n minus 1, that is 5 by 2 minus 1 into what next? Into the derivative of this factor. Derivative of 3x square minus 7x plus 3. Okay, this is equal to 5 by 2 into 3x square minus 7x plus 3 whole power 5 by 2 minus 1. 5 by 2 minus 1 will give us 3 by 2 into derivative of this. Derivative of 3x square. 3x square. 3 is a constant, x square is a function. that constant will remain as it is. Derivative of x square is 2x. So you will get 3 into 2x, I directly write that as 6x, minus 7x is there, one constant and a function. We'll keep the constant as it is, differentiate the function. So that when we differentiate this x, we get 1. So minus 7 into 1 will give you minus 7, plus 3 is there, which is a constant, and whose derivative is 0. So this is the answer. 5 by 2 into 3x square minus 7x plus 3 whole power 3 by 2 into 6x minus 7, which is the derivative of this factor. Next. Ax plus b whole power n. Ax plus b whole power n. So as always, I will treat this as y. Sorry. Y is equal to ax plus b whole power n. Now differentiate this. Y dash equal to. This is of the form x power n. What is the derivative of x power n? Derivative of x power n is n into x to the power n minus 1. So derivative of ax plus b whole power n is n into ax plus b whole power n minus 2 into the derivative of ax plus, that's equal to n into ax plus b whole power n minus 1 into the derivative of ax plus b. A is a constant here, a and b are constants, x is the only variable. Ax, product of a constant and a function. While differentiating it, we will keep the constant as it is and we will differentiate the function. So a will remain as it is. Derivative of x is 1. A into 1 is a plus derivative of b, which is 0 because b is a constant. So this is equal to an into ax plus b whole power n minus 1. Okay, next question. Seventh question. Root of ax square plus bx plus c. Root of ax square plus bx plus c. So I treat this as y. Y equal to root of ax square plus bx plus c. Now y dash is equal to. This looks like root x. Derivative of root x is 1 by 2 root x. How it is? So if I treat y is equal to root x, that root x I can write it as x to the power 1 by 2. Now when I differentiate it, y dash is equal to 1 by 2 into x to the power 1 by 2 minus 1, right? And into x power n minus 1. That's equal to 1 by 2 into x to the power minus 1 by 2. 1 by 2 minus 1 is minus 1 by 2. Bring it to denominator, it will become x to the power 1 by 2. X to the power 1 by 2 is nothing but root x. Okay? So derivative of root x is 1 by 2 root x. Therefore, derivative of root ax square plus bx plus c. You imagine this as root x. Derivative of root x is 1 by 2 root x. So the derivative of this factor will be 1 by 2 into root of ax square plus bx plus c into the derivative of ax square plus bx plus c. Okay, 1 by 2 root ax square plus bx plus c into the derivative of ax square plus bx plus c. That's equal to 1 by 2 into root of ax square plus bx plus c into, what is the derivative of ax square plus bx plus c? Ax square, a into x square. A is a constant and x square is a function. So a will remain as it is and the derivative of x square will be 2x. A into 2x, I will write that as 2ax plus here we have bx. B is a constant and x whose derivative is 1, so b into 1 is b, then the derivative of c is 0. So the answer is 2ax plus b divided by 2 into root of ax square plus bx plus c. Okay, next question. Sine 1 by x. Sine sine 1 by x. So write sine 1 by x. I'll call it as y as always. Y is equal to sine 1 by x. Now y dash is equal to sine 1 by x. This looks like sine x. Derivative of sine x is cos x. So derivative of sine 1 by x is cos 1 by x into the derivative of 1 by x. I'm using chain rule here into the derivative of 1 by x. This is equal to cos 1 by x into derivative of 1 by x. That's nothing but minus 1 by x square. That's the answer. Okay, derivative 1 by x is minus 1 by x square because you take this x to the numerator, it will become x to the power minus 1. X to the power minus 1. So its derivative is minus 1 into x power minus 1 minus 1. That will give you minus 1 into x power minus 2. In other words, minus 1 by x square. Okay, next question. Cos square root x. Cos square root x. So I call it as y. Y is equal to cos square root x. That cos square root x we can write it as cos root x whole square. Cos root x whole square. Derivative of cos root x whole square. This is of the form x square. Derivative of x square. What is the derivative of x square? 2x. So this will give you 2 into cos root x. X square, whose derivative is 2x. So 2 cos root x into d by dx of cos root x. Okay. Then 2 cos root x into derivative of cos root x, which is of the form cos x. Derivative of cos x is minus sin x. So derivative of cos root x is minus sin root x into the derivative of root x into d by dx of root x. That's equal to, this will become minus 2 sin root x into cos root x into the derivative of root x, which is 1 by 2 root x. Derivative of root x is 1 by 2 root x. You can cancel this 2. So we will get minus sin root x into cos root x divided by root x. Don't cancel that root x, not allowed. Okay. Next question. 1 by cos square 3x. 1 by cos square 3x. I'll call it as y. Y is equal to 1 by cos square 3x. 1 by cos square 3x. 1 by cos square 3x is nothing but secant square 3x. As we know, cos theta is the reciprocal of secant theta. 1 by cos theta is equal to secant theta. So 1 by cos square 3x is equal to secant square 3x. So I'll write secant square 3x as secant 3x whole square. Now you differentiate it. Secant 3x whole square. This looks like x square. Derivative of x square is 2x. So 2 into secant 3x into d by dx of secant 3x. That's equal to 2 secant 3x into derivative of secant 3x. Derivative of secant x is secant x into tan x. So derivative of secant 3x would be secant 3x into tan 3x into the derivative of 3x. Derivative of 3x is 3. Directly I'll write that. I hope you can understand. This is equal to 6 into 2 into 3 6. Secant 3x into secant 3x. I'll write that as secant square 3x into tan 3x. This is the answer. 6 into secant square 3x tan 3x. Next question. x square plus 1. Tan root x square plus 1. Tan root x square plus 1. I'll treat this as y. Y is equal to tan of root x square plus 1. Y dash equal to. This is of the form tan x. Derivative of tan x is secant square x. So derivative of this expression will be secant square root of x square plus 1 into d by dx of root of x square plus 1. Derivative of tan x is secant square x. So derivative of tan of root x square plus 1 is secant square root x square plus 1 into the derivative of root x square plus 1. That's equal to secant square root of x square plus 1 into the derivative of root x square plus 1. It looks like root x. Derivative of root x is 1 by 2 root x. So the derivative of this expression will be 1 by 2 root x square plus 1 into the derivative of x square plus 1. Derivative of x square plus 1. So this is equal to secant square root of x square plus 1 divided by 2 into root x square plus 1 into the derivative of x square plus 1. The derivative of x square is 2x. Derivative 1 means 0. This 2 gets cancelled. So I can write this as x into secant square root of x square plus 1 divided by root of x square plus 1. This is the answer. Okay. Next question. Cos sin x divided by sin cos x. Cos sin x divided by sin cos x. Okay, cos sin x divided by sin cos x. This is what we have to differentiate. Some students, what they do is they will cancel this sin, cos, and also they will cancel x. Then what will remain? 1 will remain. And when you differentiate, you will get 0. Okay, if you write that in the exam, the marks will also be 0. Okay, so you cannot cancel them. So then let us see how to differentiate this. Okay, as always, I will treat this as y. Y is equal to cos sin x divided by sin cos x. Now this looks like u divided by v. U by v. So we have to use quotient rule. What does quotient rule say? Suppose if I have y is equal to u by v, then y dash is equal to, in the denominator v square, in the numerator v into u dash minus u into v dash. This is the formula we have. So let me use that formula here. In the denominator, square of the denominator, sin cos x whole square or sin square cos x. In the numerator, v into, what is v here? Sin cos x into u dash into the derivative of d by dx of cos sin x minus u. What is u? Cos sin x into the derivative of v dash means the derivative of v, derivative of the denominator. Derivative of the denominator, that is d by dx of, what is denominator? Sin cos x. Okay, that's equal to sin cos x into derivative of cos sin x. It's of the form cos x. Derivative of cos x is minus sin x. So derivative of cos sin x will be minus sin x into what text? Into the derivative of sin x. Now I will directly write. I hope you can understand. Into the derivative of sin x, which is cos x, minus cos sin x into derivative of sin cos x. derivative of sine cos x. It looks like sine x. Derivative of sine x is cos x. So you have cos x into the derivative of cos x. Derivative of cos x is minus sine x. Okay. Whole divided by sine cos x whole square, or I can write that as sine square cos x. Okay, if you want, you cannot further simplify. Only thing is minus you can write here, and here minus into minus plus. That's all you can do. Okay, let's go to the next question. Please note down. Meanwhile, I will fill the ink. Okay, next question is tan square 1 plus x by 1 minus x. Tan square 1 plus x divided by 1 minus x. Okay, so take this as y. Let y is equal to tan square 1 plus x divided by 1 minus x. So this can be written as tan of 1 plus x by 1 minus x whole square. So this looks like tan x whole square. In other words, x square. What is the derivative of x square? 2x. So we get 2 tan 1 plus x by 1 minus x into the derivative of tan 1 plus x by 1 minus x. Okay, so first we have imagined this as x square. Derivative of x square is 2x. We wrote into the derivative of this expression. So that is equal to 2 tan 1 plus x by 1 minus x into derivative of tan of this expression. It looks like tan x. Derivative of tan x is secant square x. So here you get secant square 1 plus x by 1 minus x into what next? Say now we have differentiated for tan into, now we have to differentiate this. Derivative of 1 plus x by 1 minus x. d by dx of 1 plus x by 1 minus x. This is equal to 2 tan 1 plus x by 1 minus x into secant square 1 plus x by 1 minus x into derivative of 1 plus x by 1 minus x. I use quotient rule here. 1 minus x whole square. Quotient rule. Here only we have denominator 1 minus x whole square. Numerator will be 1 minus x into u dash. Derivative of 1 plus x. Derivative of 1 plus x is 1 minus u. U is 1 plus x into v dash into the derivative of the denominator. Derivative of 1 minus x is minus 1. Okay, further we will simplify this. This is equal to 2 tan 1 plus x by 1 minus x into secant square 1 plus x by 1 minus x into here. What happens when you simplify? 1 minus x minus to minus plus 1 plus x divided by 1 minus x whole square. Okay. See here x gets cancelled. 1 plus 1 will get 2. So 2 by 1 minus x whole square. That 2 into this 2. It will become 4 tan 1 plus x by 1 minus x into secant square 1 plus x by 1 minus x into 1 by 1 minus x whole square. That 2 is there, that 2 already I have taken here. Okay, let us look at the next question now. 1 plus sine 2x divided by 1 minus sine 2x. Root of 1 plus sine 2x divided by 1 minus sine 2x. Okay, I'll take this as y. Before I differentiate this, let us first simplify this. I'll write 1 as sine square x plus cos square x, and sine 2x can be written as 2 sine x cos x. Right? Then, similarly in the denominator also, I am writing 1 as sine square x plus cos square x, and sine 2x can be written as 2 sine x cos x. Okay? So then, this is equal to root of, this looks like a square plus b square plus 2ab, which can be written as a plus b whole square. I'll write this as sine x plus cos x whole square divided by, again here in the denominator, a square plus b square minus 2ab, that will become a minus b whole square, sine x minus cos x whole square. Okay, so root of sine x plus cos x by sine x minus cos x whole square, I can write that as sine x plus cos x divided by sine x minus cos x. Okay, now I will divide this by cos x. Dividing by cos x, both the numerator and denominator you divide by cos x. Here sin x by cos x will become tan x. This will be 1. This will be tan x minus 1. Okay? I'll take minus as a common factor here. Minus of, I can write this as 1 plus tan x divided by 1 minus tan x. 1 plus tan x divided by 1 minus tan x. That is equal to tan of pi by 4 plus x, which you know already. Tan pi by 4 plus theta is equal to 1 plus tan theta by 1 minus tan. So y is equal to minus tan pi by 4 plus x we have got. I'll write that again here. Y is equal to minus tan pi by 4 plus x. Now you differentiate. Y dash is equal to minus secant tan x. Derivative of tan x is secant square x. So minus secant square pi by 4 plus x into the derivative of pi by 4 plus x. Derivative of pi by 4 plus x. Pi by 4 is a constant, so its derivative is 0. Plus x is there, whose derivative is 1. 0 plus 1 is 1. 1 into this will remain as this only. So this is the answer. Okay. Next question. X cos x by root 1 minus x square. X cos x divided by root of 1 minus x square. X cos x by root 1 minus x square. I treat this as y, let y equal to this. So this is on the form u divided by v. We have to use quotient rule. Y dash is equal to quotient rule. What does it say? In the denominator, square of the denominator. Here we have root 1 minus x square. Its square is 1 minus x square. In the numerator, root of 1 minus x square into d by dx of x cos x. Here I have to differentiate this x into cos x. Minus x cos x into d by dx of root of 1 minus x square. D by dx of root 1 minus x square. Okay, this is equal. Denominator is 1 minus x square. Numerator is root 1 minus x square into derivative of x into cos x. Here I have to use product rule. X into derivative of cos x is minus sin x plus cos x into derivative of x, which is 1, minus x cos x into the derivative of root 1 minus x square. Root 1 minus x square, this looks like root x. Derivative of root x is 1 by 2 root x. So derivative of root 1 minus x square will be 1 by 2 root 1 minus x square into the derivative of 1 minus x square. Derivative of root 1 minus x square is 1 by 2 into root 1 minus x square into the derivative of 1 minus x square. Derivative of 1 minus x square is nothing but minus 2x, because derivative of 1 is 0 minus the derivative of x square, which is 2x. Okay. So now this is equal to root of 1 minus x square into minus x sine x plus cos x. Here 2 gets cancelled, minus into minus become plus. Here already 1 x is there, along with that x, it will become plus x square cos x divided by root of 1 minus x square whole divided by 1 minus x square. Okay. Students, with this I will stop today's class, but I'll give you a few problems as homework. You try them. Question is same, find the derivatives of the following functions with respect to x. Okay. Sine root x divided by root x. Then cot square x minus 1 divided by cot square x plus 1. Then sine of x divided by x plus 1. Solve these three problems, and in addition to this, you solve the problems from the second exercise of this chapter. Okay? In that I have solved few, whatever that I have left, you try them. If you have any difficulties, you can ask questions in your WhatsApp group. Thank you.